The autonomic nervous system is responsible for the body's visceral reflexes. These are unconscious, automatic, predictable responses to stimulation. They're not unlike the somatic reflexes like the knee jerk, but their receptors and effectors involve the internal organs, and their responses are slower. Autonomic reflexes involve a visceral reflex arc. This reflex arc consists of 5 components. First, sensory receptors that respond to an array of stimuli like stretch or tissue damage or blood chemicals, body temperature, etc., are stimulated and generate a nerve signal. Second, afferent or sensory neurons carry that nerve signal to the central nervous system. Third, the nerve signal arrives at an integrating center in the central nervous system. A chemical synapse takes place between the afferent neurons and the interneurons of this integrating center. These interneurons analyze this and other sensory data and make the decision as to what response from the visceral organs is appropriate. The fourth component is the efferent or motor neurons. The interneurons of the integrating center synapse with the appropriate efferent neurons, which carry those motor nerve signals away from the central nervous system and toward the tissue or tissues that will carry out the response. And the fifth and final component is the effector. This is the tissue gland or organ that will carry out the desired response to the original stimulus. In most cases, these visceral reflexes maintain homeostasis in the body. A good example is when high blood pressure triggers a response aimed at lowering the blood pressure back to normal. The elevated pressure stimulates baroreceptors in the carotid arteries and the aorta. Nerve signals are generated and propagate along the glossopharyngeal nerves to the medulla oblongata, which is the integrating center. The medulla sends nerve signals along the vagus nerve to the heart. Since the vagus nerve inhibits cardiac muscle, the heart slows, and in turn, blood pressure decreases.